Now let us bring in this idea involving this percentage composition by mass. I think this is interesting and maybe require a little bit of time to talk about it because it is not very intuitive. So the percentage composition by mass of each element in a compound can be calculated as such. The percentage mass of your element in a compound is equal to the percentage molar mass of your element in a compound. So based on this idea, we will have the mass ratio to the molar mass ratio. Mass of element to the mass of compound equal to the molar mass of the element to the molar mass of the compound. So where does this idea come from? So what's the rationale behind this? Maybe we use water as an example because everybody is familiar with water, right? We know water is made up of 2 hydrogen and 1 oxygen. So if I have 1 molecule of water, since water is H2O, I know that 1 water will contain 2 hydrogen and 1 oxygen, correct? What if I have 1 gram of water? Now in 1 gram of water, the percentage of hydrogen to oxygen will also be the same, 2 hydrogen to 1 oxygen. What if I have 10 grams of water? The ratio for hydrogen to oxygen will still be the same, 2 hydrogen to 1 oxygen, because it is a compound chemically combined together in a fixed proportion. So regardless of the quantity or the mass of water, 1 gram, 10 gram, 1 kg, 1 ton of water, no matter whatever quantity or whatever mass of water that you give me, the proportion of hydrogen and oxygen is fixed, won't change one. Always 2 hydrogen to 1 oxygen. So that is the basis. That means if I have any quantity of water, 1 gram versus 10 gram, or 1 gram versus 10 kg, 1 gram versus 1 ton, the proportion of hydrogen to oxygen is fixed for both scenario, or the proportion of your element to the entire molecule, your hydrogen to water, or the oxygen to water, is also in a fixed proportion. So if I want to do calculation, of course, I want to reference it to something that I can do calculation, correct? So I reference it to what? I reference it to molar mass, mass of 1 mole of your compound. So why do I want to reference this to molar mass? Because this information I can find from the periodic table, I can do calculation involving that. So the expression is actually based on this. Basically what we are saying is, if it is a compound chemically combined together in a fixed proportion, the percentage of the element to the whole compound is fixed, regardless of the mass of the compound. So what I do is I use the percentage mass, this mass ratio for your element to your compound. I tag this to molar mass. Because molar mass, I can pull this information from the periodic table and then I can do calculation based on that. Alright, so in this case, if, again we use this as a simple example, if I want to find the mass of oxygen in 10 gram of water, then mass ratio is equals to molar mass ratio, mass of oxygen to mass of water. This is the unknown term. Water is 10, it's already here. Molar mass ratio, mass of oxygen, which is 16, atomic mass, and mass of water, which is 18. So you notice now I have an equation, there's only one unknown term, so therefore I can solve for the unknown. And I can determine the mass of oxygen inside this sample. This calculation under certain circumstances will be useful, so I think it's good to keep this in mind. Hopefully after this clarification, we roughly have some appreciation involving this expression, because some of the formula, when we talk about it, if you don't really understand what this is talking about, then very difficult for us to find opportunity to try to apply this. If you don't understand it, you don't know when you can apply that.